We need to know about the relative strengths of ammonia and the amines as bases. Okay, now why are all of these basic, right? And this is an exam question that you need to say the following points. Okay, you need to say that this will state the obvious: bases accept H plus ions, they accept protons. Okay, and secondly, the lone pair on the nitrogen attracts the H plus ions. And then say the more available the lone pair is, the stronger the base. Okay, so we've got to bear that in mind. Now, which is the strongest base out of this lot? Well, the weakest base, I can tell you, is ammonia. This is the weakest. Now, it's a weaker base than the primary. It is a weaker base than the primary amine. It is a weaker base than the primary amine because if you remember, back when we were talking about stability of carbocations in the alkenes topic, remember that we said that alkyl groups have a slight tendency to donate electrons, negative charge. They push negative charge away from them, and sometimes we draw it as a little arrow like this. Okay, so you can see that the primary amine, the lone pair, is going to be more available because you've got one alkyl group pushing charge into that nitrogen. If we then think about the secondary amine, here's the secondary amine, that should be even stronger because here you've got two alkyl groups pushing a bit of charge into the nitrogen. And finally, you would expect the tertiary amine to be strongest as well because you've got three alkyl groups each pushing a bit of negative charge towards the lone pair. What we haven't discussed there is is phenylamine. Okay, so let's have a think about phenylamine. I'll draw that in a different color. Right, now phenylamine is a very weak base. It's much weaker even than ammonia. Why is it such a weak base? It's because that lone pair is partly delocalized on the benzene ring. And that makes it less available. So it's less available to accept positively charged hydrogen ions. So that's the weakest base of the lot. Now you may think, how do you actually quantify these? Well, that's all you need to know for the A level. That's all you need to know. And you do really need to those 3 points. It will very often be a 3-mark question. But just to say very briefly how you can quantify them, we've come across Ka. Well, there's something called Kb, which is related to Ka. So if you think of ammonia, has a tendency when it reacts with water to form the ammonium ion and hydroxide ions. And Kb is just defined as the concentration of the NH4 plus OH minus divided by the concentration of the NH3. We don't put the water in there because we consider the concentration of water to be constant. So you can see the further to the right that equilibrium is, the larger Kb will be larger. So I've got a few values of Kb's, which I will just write down here. Okay, so for ammonia, remember we want this, the bigger it is, the stronger the base. Ammonia is 3.8 times 10 to the minus 10. Let's do this in a different color. That's 3.8 times 10 to the minus 10. Ethylamine is, sorry, not to the minus 10, to the minus 5, I beg your pardon. Bit of a difference. And here, this one is 4.4 times 10 to the minus 4. So it's getting on for 10 times stronger than the ammonia. I don't have a value for the secondary, but again, it will be a tiny bit bigger. And the values for the tertiaries tend to be hard to come by because tertiary amines are not terribly soluble in water, so it's hard to find them. Now, if you look at interesting, if you look at the value for phenylamine, it's much smaller. It's 3.8 times 10 to the minus 10. So that's like 1,000,000 times smaller than that one, isn't it? It's a huge difference. It's a much weaker base because of the delocalization of the lone pair onto the benzene ring. Okay, so that's basically all you need to know, but just briefly, we'll just say there's been a question once. It gave you a range of compounds like this. One like that, and finally one like that. Okay, and it said which is, let's call them A, B, and C. A, B, and C. Which is the strongest base out of those three? Well, maybe let's just say which is the weakest. This is the weakest because the lone pair on that, although it's a secondary amine, because the nitrogen is attached to the benzene ring, the lone pair is delocalized or partly delocalized. Now, this lone pair on this one is not delocalized because the carbon is not directly, the nitrogen is not directly attached to the benzene ring. There's one carbon in between it, and that's as good as it could be 1,000,000 miles away from it. That is not delocalized. So that is what we're looking at there, is just a straightforward, that's a primary amine. Again, the lone pair on this nitrogen is not delocalized because it's too far away from the benzene, and so it's actually a secondary amine. So the answer to that question would be C would be the strongest because it's a secondary, B would be the next strongest because it's a primary amine, and the weakest would be A. Even though it's a secondary amine, I suppose the nitrogen is attached to a benzene ring, the lone pair is delocalized.